at least one memory on Brazil I should add after this. Before I even met Jean-Pierre, I was in Brazil, and I was in Brazil at a time when I thought I'd give up to do quantum optics. I will not make a big thing there. I will do a lot of mathematics. I was in Brazil, and I thought I moved to Brazil. So, but the great physicists there told me, come as qualified as you can be. So I did a PhD, and I continued. And I had the bad luck to meet Manfred Eigen, and so everything turned the other way around. Now, as to Vera's talk, and to my talk, two memories of my many stays in Brazil as a guest professor in Recife. Actually, you saw on the book Action Potentials, Caruaru, which is a capital, the musical art. Two memories, one on 1980 with Wolfgang Hanke, and one on 1989 with Steve Leon and Chris Martins Ferreira on spreading depression. I had with Wolfgang, he tells through all details. He was almost finishing his career by finding that asteroids causes channels. So we had this in the early 1980s. It's itself a big story. So after I had it, I immediately wrote my first habilitation thesis. I had to write another one, but it was just succession, and Manfred Eigen pushed it through at the end, whatever. This was 1980, so immediately after I had written that habilitation on Acetylcholinesterase und die physikalischen Grundlagen der Nervenerregung, I left to Brazil. I just went. With Regina, she already got involved in it and became a professor for Brazilian music later in Vienna. So I went to Brazil in 1980, and but I was already tagged, you know. I couldn't leave to Brazil because we had the asteroids I had predicted in 1977. It's all at the book exhibition in the coffee room. So this was 1980, and in 1989 I had more or less finished. I wrote all these books, these things about action potential and so on. And you saw that they were printed in Caruaru for reasons which you can imagine. They were all printed, and I would change a comma there, but there is one mistake, and Daniel, if he's still around, he found it all alone, and Matthias also found it. And maybe you find it also. It's a number mistake, but just in a factor of 1,000, so forget about it. And in 1989, so I had this theory of action potential, which I don't talk about now. And I immediately checked how I can get into brain. And then I had a theory of brain, and I will largely talk about brain theory today, but on a much higher level. And then the spreading depression I had learned about in Brazil. And I was very excited, and it was the first thing to test whether my brain theory is wrong. And since the whole theory is reversible, we discussed yesterday, so I checked that, and I saw all these measurements. It was before or just at the time when also Tasaki started coming to Göttingen and then started to measure. So it was a test of brain theory. So I felt I do a reversible theory, and this is a mess of things, but I had already details. So let's kill it and find out whether the whole damned brain can be reversible. How stupid, I mean, what is in the thoughts has nothing to do with reversible. So I did the theory for that, and maybe I come later on it, and it went well, very well. We had an even MRI experiment, whatever, and so it confirmed for me I can continue. I did not have the details. So that was, and his Martins Ferreira and Aristide Leon arranged that I could get a professorship in Rio de Janeiro. Ilya will come down Biophysica. It's a big story, and Regine was very upset that I did not go to Brazil. I just couldn't. And I started. So I lost now 5, but of course this is full of music, and I had performances. It's incredible, whatever. Now all my kids got fans of, so that went well, but me, I just stayed whatever. What I tell you today is on a backward view. So I don't go through the whole story, and I look from today backwards. And I will only present you what I did since end of last year, when I went with the students from Dortmund and Göttingen to Stockholm Nobel lectures. And only from there you get, did you distribute this first thing already? Yes. And I start with that. So I will go, and I did this thing around the Christmas holiday, last one. Yeah? I put it out, it was the first time I could get the whole thing on one page. So with this I start, I go with you through where my theory is now, but of course it can be falsified. All the things are in this book here. So I copied from this book, and I give you exactly where I stand now, and there are falsifiable predictions as usual. And I just go to it. And so I use the first time and give me a note if a quarter hour is over or 20 minutes. If I'm not through this thing, this beautiful blue pen. So what's new?
You already have 7. You already have 7.
That's life, but I have eliminated time from my theory. That's my way of. So, what's new? What's new? And I give it the following symbols. I take, you see it in Einstein's books, which are outside at the beginning of relativity, the fundamental formula since Euler. In physics, I don't go to the details. I just give this formula. That's the basis of principle of least action and so on. I don't start even to talk about, but all books to learn about from people who know about, not just authors who have no idea and give you ways to talk about without understanding. And I introduce only one more symbol to it. It's very recent. I did it and I play at the moment with to do the logic of Russell and the Gödel thing, even with the written down formal logic, but without the Gödel. So this is new. I only add this symbol, and this symbol says whenever it appears, I now look into the real brain. Just in the brain. I observe into the brain with all the mess of things, and I go now with you through the result. We can do all details. I have copied all or most of the book, so whoever is interested of you to go more into, I will send you. I could give you now, but then you have to carry it. If you leave your address, it's here. Another technical remark. Till end of April, I will be in Göttingen. Everybody is invited who has the time. At the end of April, last Sunday, 28th, I will have my first performance in the Deutsches Theater. I was involved in many things, but it's the first thing I do all alone. I do it in honor of Manfred Eigen, who just died, and it's called Die Kunst der Wissenschaft Manfred Eigens, the art of science, Manfred Eigens, and they printed of the program only 3 sentences. The first is, how does a musician come into physics? And this is the second, what is the secret of the 1967 Nobel Prize in chemistry? This is Manfred Eigen. And the last is we compare Eigen, Heisenberg, he heard Heisenberg. I also discussed with Heisenberg still. and Eigen, Heisenberg, Planck, great things on music he did before the war, and Einstein. He played violin, he also played piano, and I have documents now that he would have become, he said, a musician if he had not fought in the track. Okay, I just start. And I start with the result and I go backwards. Yeah? I have something like 50 full written books, largely wherever they are. I just start. So what's new? So this is totally new. You start from looking into the brain. You don't talk the great philosophies, there's nothing new under the sun, under the sun. I start from looking into the brain. I give you strictly observables of the brain after I had the theory. So I give you the end where I stand, not how I came to it. I show you where, when you look at the brain, what you reduce, what you change, how do you come to physics, and to mathematical physics, and to Russell's logic as far as I can tell now. I mean, I have read these things before. So this is my approach. When this sign arises, we look into the brain, and I will deduce from the brain the following results, which I just put here, which are largely the things we were discussing here.
May I briefly ask, what is S?
This, now I have to go to the physics. In physics, this is a pretty, well, I have to put, if I do it, I do it properly.
Is it action or is it...
No, I give it properly. This is since Leonhard Euler, in something Leibniz has opened up on the basis of Aristoteles' Entelecheia, which he cites. This is a principle of least action. The sacred thing where Lagrange has introduced time and so, and basically, and they would not go to the downs and take what we observe with our blind eyes and our selected observation, which changed everything in a few decades. They did it with numbers. And numbers coming from geometry and with all the story. So whatever they introduce, and you see it outside, I put it from Albert Einstein when he started general relativity. It's there on the table. There he starts from that, and Albert Einstein introduces this four-dimensional thing and so on. This is the starting point. So you have something with numbers. It can be just numbers, it can be observed numbers. The mathematics doesn't care whether you deal with observation. And it's used for the numbers we observe in the lab with our things. Né? And I will use it then looking into the brain for that. Yes? It can be very complex. Gauss has introduced uncertainty into that here, into the numbers. Neither Einstein nor... okay, I don't go into that. And this is a variation of, so this is our usual differential, which looks very different when we look into the brain. This is an integral, so you have the path, and then you make another variation to get the least path or so you know what is a straight line, and these games. So this is a principle of least action since Euler, which Lagrange has spoiled. I'll give you that. If I have to answer this, I have to do it properly. He has spoiled, and Gauss put it out, and it is not my subject now, because I want to get... My subject is at the end, I give you the solution of the two Gödel paradoxa, which Einstein and Gödel lived together with in Princeton. This is my goal. I want to give that, and I do it backwards. I give you the solution first, so you have it, but how it's done, I go backwards. So, meaning, you put something with numbers, you take a continuum, since Aristotle, you integrate over, so you make a continuous description, and you integrate over, and then you look which is the shortest path in this abstract S thing. Okay? And S will be the crucial thing later, our selection and observation, because it's much more important what we do not observe. And what we all of a sudden will see in 50 years, and we have to change everything. And then we have the language, we cannot get out of the language. We are exactly there at the membranes and these things. But I go backwards, I come from the other side. So this is a principle of least action. I show you by looking into the brain and after a long time and doing all kinds of games with it, including spreading depression, where these things arise and what we very much reduce in physics. Is there a clock? No. How many minutes did I abuse now?
Nearly all. You have already come 15, 16 minutes.
But don't I have 40 minutes?
Including everything, no. Including questions and everything.
Yeah. Okay. So I just go with you to the paper, which I did, and the rest we do in the questions. So what is new? What is new is that this principle of least action, which is then put to zero in order to get the minimum path, and the other second worldview we have today of uncertainty, which is based in all the things we did here, including the past. It is based on capital S for entropy, and second derivative for Gauss least squares, which is the origin of the law of entropy of thermodynamics, of which I don't talk now. And if you have these variables, these are observables, numbers. This is the key of uncertainty in all of Einstein's theories, in all of these things. But Einstein never brought these two things together. He did this for relativity, he did this for quantum theory, and we can go through it. So what's new about it? These two things are identical. If you do the least, this is the result of Gauss. I have no time to go through it. I can totally go. The whole last year I was with Silly and all the time in Jerusalem, in the Princeton, whatever, for it is identical. It's one and the same thing. Gauss said so, but he did not put the equation of entropy. It was not around. Boltzmann, I don't go through the history. Boltzmann, the first paper, he said such a thing, of course not yet in this formulation. That's a formulation we have to do. So that is new. From this was content of our conference, and I don't lose a single word on it. I just write here action potential. From nothing else than this one, action potential. And I write here catalysis. I have exhibited it because only Silly was talking about it. And I wrote here, right here, the quantum. And the quantum is exactly done from this by Planck and Einstein in the original papers. And they are out there. Planck-Einstein. This is just Planck-Einstein, the one world view on uncertainty with all the paradoxes I don't call. And this here is the principle of least action, which we have seen from Aristotle till Euler in the correct way, and I don't copy all these things. And we have this in relativity. And so on, and we have it at the fundamental, the law, I call it the law before the laws. But not in this sense, but in this sense. In this sense, it is the law before the laws, which John Wheeler was saying that's the point. To look for before the laws. Before the laws, and the laws are all of our fields before the laws. The rest you have on your paper, and I will now talk about only, and here this I will not touch anymore. It's one law, very important. And the experiment which made it final was Schmidt's thesis. Finished. It's one law. He didn't see, I was not sure, that his optical measurements prove exactly that law. It's based on all these things, and the light intensity is exactly going as Einstein 1916 said. But I have no time to dwell on that. So here we have a relativity, and it's all on the paper. I don't do it. But here I come now to what is so...
Just a commentary. You have to use 20 minutes, and I put 10 minutes on. Then I stop you exactly, right?
But I had eliminated the clock.
Huh?
It was an error of Lagrange to introduce the clock, you know. Okay. It was a fundamental error. All the big things come from it. So maybe I stop here. You have this little...
No, you can go again.
No, you have this little page where all these things are on. So maybe I switch right away, please, Antoine, to the next one. He will give a run, and I go right away to the next one, which is now the derivation. Which is now the derivation of the whole thing, and this is the brain's first principle. Brains first as we observe it. And it is the law before the laws, and if I look into the brain, I do this game, then I see the following, but don't invert the argument. Don't look in the brain and derive these things. You have to have the goal in front of you. Here we have, say, 6 layers. 1, 2, 3, 4, 5. For instance, it can be different in the retina quite the same way. In these layers, we have exactly 3 principles, as we have here. We have from the input-output, which I give the Ramon-Ikahal notion from 1911. It's still true, so nobody writes about it, nobody learns it. You cannot make a big point there. You have this one, which I call S. Here's all the selection happening again and again and again and on many. Then in the top is a kind of axonal layer. It's only a special case, don't take me. This is all a brain's first exemplificatia. For example, you have it in the spreading depression just the same way, but I cannot put it so well. So when you have this, that these action potentials are directed and annihilated, collision and all these nice things, this is where the integral enters. This is where one thing is the same as the other thing. And now this very important variation, looking only for the changes again and again, is happening again and again here in everything in between. So you couldn't call it inhibitory synapses. I don't write this down because I don't want you to pin me only down to this. You see it everywhere. So you have an observer. So here I put the observer, the eye which he cuts so nicely, puts in his threaded along, the beginning of brain science in modern time. And here you have to make the selection. You select, you are blind. Face it, we are blind. We can do it with the ear, we are blind again, and so on. But it must all the special cases be below the law before the laws, and it can be falsified. What I say can be falsified by anything which whenever can be thought of. It can be falsified. So it can be falsified, for instance, by logic, formal logic, which Russell brought on the top and on which I will talk now, which is only 2 principles. It's 2, it's binary. Logic, true or false. Anything in between is meaningless. That is since Aristotle like this, but Aristotle was aware of Zeno and was busy with the syllogisms. I don't talk about it. So, there he has 2, and we have 3. I just point this out before Thomas kills me, which is intense in several decades, but still, let's see. So, I have 3. The brain has 3. And they have a very different meaning. They have to go very much down. And formal logic has 2. And it has a fantastic ability, this logic, not to be creative all the time. If you buy a computer like the brain, nobody will buy it. The computer will be creative and not listen to you. What can you do? The problem people have with every composer. It's nice to have it written down. So, I should now make a switch. I make this point. So here with this, I solve the Gödel unprovability paradox. I leave it to the discussion. This logic, which has a Gödel paradox, is an extremely special case of the unnumberable creations of the human brain, which will continue. That's a key point. And I have all the texts here from Gödel, Einstein, Russell, 1944, in a wonderful volume, and all things are outside. So, I come to the next. Antoine, there is still a next. It's already going around. So, what is on the next? I just have to be where you are. Welche hast du jetzt? 2? Ja, okay, exakt. So now we are here. Yeah, ich nehme den mit. We are here, and I put here musical examples, and I cite Gauss, and I leave it now all to the discussion. Right? We just go through these 2 pages, brain physics brought to speech. Jean-Pierre has said everything about the problem of speech. There's nothing new under the sun. Once you start reading not only Aristotle, also the pre-Aristotelians, which are largely only whatever. It all has been said, even if you go to the Chinese, which I don't dare, but meanwhile I even dare that. So we go through that, brought to speech, and the big problem of speech is leaving this circle away. So you create speech, just as you create logic. And we do it for different languages, and where we are blind, and where the music, which Vera was showing, is raising something. So you are in Mut, if you have written your habilitation thesis, you are in Brazil, you don't know what is going on in Bochum now with that thing, yes? And it's going on for 40 years only. The times can be much larger. And with the rediscovery of Gauss identity, so this is Gauss, which I leave out, but this is Gauss. This was 1820s, 1821 to 1829. I leave that subject out. And now we go to this thing, and we just read it once. So brought to speech. So observe. I don't know, I have time. I have eliminated time. So observe. See now, from that view, the law before the laws. And it's not just a mathematical addition, it's a creation of mathematics. And now go through the next. Where is that law? It's in the brain. Now look into the brain, and you see it's unifying. So this grand goal of unification is there. The concept is everywhere the same. It is absolutely happy and excited. And it doesn't matter whether you put a god, or even better, a goddess of the Greek, wonderful, what can you ask more for, right? So, but it's unifying. It's unifying, and then the question is how much pleasure you do with the logic and so on. Now we go through it. The physics laws derive, and I don't go further than that. U is only the identity. 2 worldviews are one, full stop. The 20th century debate is gone, is over, and they all know it's from thought. They all put it in words, And I say we look into the brain and we look from all this viewpoint. Next is paradox logic, has 2 only, instead 3, and 3 are unifying. We see it in the cortex, and we see that they are inseparable. You cannot have one independent of the other. There's nowhere anything like that. They are all together. So this is all lacking in the reverse approach to have the physics and then try to do the brain. So now I'll give a word to it just for acoustic communication through the air with you. I call this one symbol and, I call the other one or, and the third one with a blind watchmaker and blind observer I call not. I don't use more words, and it's not the and and or of the bi-valued logic, but it is very close to it, so we can communicate a little. And then the whole thing, the variation principle, without looking at, is the variation of an integral of the differential of with the observables. That's our God still. There may be something else later, and other cultures have something else. I can go through you with through the bossa nova of Antonio Carlos Jobim, and I think I can finish here, because now we just look into the brain, and we see the paradox is created by the choice. The choice in observation, instead of as with a circle. And the last point is, which I put here, and this you see in the brain. And you could have falsified, and you can still falsify on any field. And then the right-hand side I leave to you to read. And do I still have more than that? I have more things. What did Antoine do?
He had to go to the doctor.
No, he is leaving. So can you just distribute it? But I don't talk about it. So here we are, discussion.
Okay, thank you, Conny. I want to make it clear that I have no intentions of killing Conny. It would deprive us of a spectacle that we...
What's new? That's you.
Conny, I have intentions to kill you.
Yeah, I know that.
Up here is a question.
Now let's start.
Okay.
Okay, so Conny, you announced to solve Gödel's paradox.
Yes, no, I solve.
Okay, so what I basically perceived is you pointed at some spot at the whiteboard where it's written a 2 and a 3, and I imagine you intended to be a single 2 and a single 3. It also could be a 23, I'm not sure about that, but basically it was a little bit too fast the way you solved Gödel's paradox.
I say something.
So maybe you could elaborate on that a little bit more.
I say something. The whole Gödel thing was based on the 19th century development of formal logic. And the culmination of that formal logic was Peano's logic of numbers. That was both for Russell and for Gödel the real foundation. And so what Gödel did is to take this bivalent logic in the form Russell has put it in 1910 in the first edition of Principia Mathematica with Whitehead, and he has just used it. He has done exactly what Aristotle told Zeno had done. Zeno agreed, came to a marketplace of Athens and told the people who were supposed to know about Aristotle's logic, all creeds are liars. And Gödel has nothing else than exactly take the formal logic of Russell and in this formal equation-like way to, in this way to talk about logic, in this formal way he has written the formal equation that this is not provable. Just like Zeno. He has done the same thing. It's the basis of the whole. And then this is put into all the definition of symbols, and I give you nothing more except I look into the brain, and which special case they are dealing. So a Gödel paradox is just proving that the logic is not how we think.
But his question was, what does it have to do with the 2 and the 3?
No, and that they have 2 is obvious. Gödel, since Aristotle, yeah, they have something must be either true or false. Any third possibility in between makes the whole statement meaningless. It doesn't say anything in terms of logic. So that's a 2. That is, no, millions and thousands of years. The 3, you have all liberty to make more out of it. I can give you how I strictly derived by symmetry argument 3. Yeah, okay, so and 3 is the minimum argument. If you have more, you still have solved.
So there was another question?
Yes, no, maybe. Yes, no, maybe.
Let him kill me, that would also abbreviate.
We will discuss a few things later.
So you take the microphone, so you claim on that.
So you basically make the statement that the brain is constantly creative, and that's something everybody can attest to. I think.
Of course, everyone
But you
read l'homme neuronal of Jean-Pierre. Everything is there.
but you still argue that there's a stable, non-changing law.
In my thought,
Okay.
which is
Can you
reducing
comment on this?
these things as well, I'm by no means at the end of the story of creativity.
But you think that this law is somewhere above the creativity because it explains it?
Well, I think it's always the same thing which happens. The Ptolemies had these wonderful observations of the sky, and there came up the Gödel of that time, whose name was Copernicus, and just let them look from somewhere else. And then one had to redo it all. It came again to numbers and again to Aristotle until it's still the same story. And then it was done, and Newton came about and put it very precisely. And then came Einstein and wiped it away. And already Boltzmann, the young one. And how long it takes, that's a different question. So it came again and again. It was true for everybody. And if we are through, and I say we are through, so I take the whole way back, but in a falsifiable way. So you can always falsify still, and I'm 20 years after these things here, 30 years since '89, and looking for contradiction to falsify. But it's a present state, and this is a state I have one confirmation from Ramon y Cajal. In the histology, I have it from the spreading depression, which could have ruled it out, and from anywhere, wherever you come from. So that's where I am, and there will be new generations with new measurements I have no idea about, and I can even not imagine what will be the paradox in another generation.
Okay, is there some other question? So if that's not the case, let's thank Connie again.
And please leave your name somewhere. There's my poster and address, and you will get 22 pages of these things from my book by mail.
Okay, we have